Hey there folks, Mr. G here with another educational video. This time we're going to actually use all of the knowledge that we've gained about variables and expressions, all that sort of stuff, put it to work solving some equations. At the start of the year, we solved some problems related to things like this, where we had some sort of blank here that we needed to fill in to make the rest of the equation true. This blank right here is what we're going to substitute with a variable. Let's say we take everyone's favorite, x. So we could rewrite this as an algebraic equation, x minus 4 equals 7. So what number minus 4 gives us 7? Now you might be able to solve this offhand, but let's see a few different strategies about how we might solve this that'll help us solve some of the more difficult versions of these types of problems. The first technique we can use is using algebra tiles. So let's draw this out using algebra tiles. If we did, it would look a little bit like this. Now at this point, it might not be clear what we're supposed to be doing, but there are two key rules anytime we're trying to solve an equation. Key rule number one is that for an equation to stay equal, we have to do the same thing on each side of our equation. So if we added 1 or 10 or multiplied by a number on one side, we'd have to do the same on our other side. The other key rule is that in order to solve an equation, to figure out what this variable is, we have to end up with our variable equals some number. So no other mixing or anything here. You'll notice here we've got a variable and a number equals another number. That's no good. So in this case, what we need to do is we need to get rid of this piece right here. This is in the way of giving us variable equals number. And in order to do that, to get rid of this piece, we have to do something to this side of the equation, but then do the same to the other side. If we have a negative 4 here, we could cancel this out by adding 4 to this side of the equation. But then we would have to do the same thing on our other side. These would all cancel out with each other, and then we would end up with this right here. Notice now we have variable, our x, equals a number. In this case, we would get 11. So the answer to this question would be that x needs to be equal to 11. So that's one technique for solving this using tiles. We could also solve this equation without tiles. But for this, we would use the same steps. Here we added 4 on both sides. We're going to do the same thing using this equation. We're going to add 4 to both sides. This 4 and this negative 4 would cancel out, and then we would end up with x equals 11. Before we move on to our next example though, I want to show you something. Whenever you're doing these equations, you can actually always check your answer. And I would encourage you to check any answer that you get, especially if it's on a quiz or a test. In order to check that, what we want to do is we want to take our original equation, x minus 4 equals 7, and what we're going to do is substitute in x equals 11 and see if this is equal. So does it work out on both sides? When we substitute x equals 11 in here, we would get 11 minus 4, and 11 minus 4 is equal to 7, so these two sides would match. That tells us we got the right answer. What about this equation right here? This one's definitely a little bit harder. And unlike our first question, you probably don't immediately know what the answer is. So again, we're going to use our two different techniques, tiles and no tiles, to help us solve this. We're going to start with the tiles though, because it oftentimes will tell us what sort of operations and what sort of things we need to do to solve our equation. So this is what our equation would look like with tiles. Now the first thing, we know that we want to end up with variables on one side and number on the other side. So my first instinct would be, well, I've got an extra number here that I don't want. So I'm going to try and cancel this out. So if it's a positive 1, I would need to put a negative 1 here to cancel this out and move it over onto our other side. And we would end up with something like this. Now, how do we cut down variables on one side, numbers on the other side? We're almost there. The problem is that we want a single variable. We don't want 3 copies of our variable over here. But notice what we can do. Every variable lines up with 2 negative 1s on the other side. So if this is an equation, these perfectly balance out. That means that one of our variables needs to be the same as 2 of our little pieces over here. This needs to be true in order for these two things to be equal. And now we have variable equals number. Now we have x is equal to negative 2, and we have our answer. If we wanted to solve this without tiles, now we can use these tiles to help us build up our intuition and what sort of techniques we want to use. First step, we're going to subtract 1 from both sides. We'll end up with 3x over here, because these will cancel out. Negative 5 minus 1 would give us negative 6. And this grouping idea, the fact that if 3 of our variables equals 6, negative 6 total, each of our variables should be equal to -2. And grouping them like this, taking all the stuff on one side and splitting it into 3 groups, all the stuff on the other side splitting into 3 groups, this is going to be the same as dividing. We're dividing up both sides into 3 groups. So what we're going to do on both sides of our equation is we're going to divide by 3. You could write it like this with our fraction. The other way that sometimes people like to write it is they'll write a little divide by 3 on both sides. I personally like the fraction. I like drawing it out where I've got a fraction and then another fraction here. That's me personally. If you like the other way, that's fine, but I find this leads to fewer mistakes. If we've got 3 divided by 3 here, those will cancel out. We'll end up with an x. -6 divided by 3, that would give us -2, and we get the same answer in both cases. Once again, it's important to check. So let's take our equation, 3, substitute in x is equal to -2. This would be equal to -6 plus 1. -6 plus 1 is -5. Right side equals left side, so we know we got it right. I also wanted to quickly mention that in these questions, the order that you do it really does matter. In this case, we subtracted 1 and then divided by 3. If we did it the other way around, if we started with 3x plus 1 equals -5, and we divided both sides by 3, notice that we would be dividing this and this. We have to divide everything on one side and everything on the other side. And if we started like this wouldn't always just cancel out. We wouldn't just be left with an x, because we have to divide this 1 by 3 as well. And also, this isn't going to give us a nice number. This is going to leave us as a fraction. So keep in mind that the order that you do stuff matters. This is not a great way of starting our problem. Our last example here, now we're going to have a variable divided by a number. In this one, we had a variable times a number. In our first one, there was nothing next to our variable. Now our variable is being divided. In this example, algebra tiles are only going to get us part of the way there. We're actually going to have to add a new type of diagram for this. And that's going to be because we don't really have a way of drawing out a variable divided by a number here. But we can remember that this means divided by 4, which is like divided into 4 pieces. So our x is being split up into 4 pieces. If we think of this circle as being our entire x, then x divided by 4 would be this split up into 4 pieces, and we're just going to take one of our pieces here. For the rest of this, we can still use algebra tiles. We know how to draw out -3 using algebra tiles, and we can do the same with -6. We do the same logic that we did in our previous examples. Here we're going to have to add 3 to get rid of the numbers on this side and do the same thing on our other side. And now we get that 1/4 of our variable is equal to 3 of these negative tiles. But what we want to solve for is what is our entire variable, right? We would want all 4 of these colored in. That would be our entire x. Well, that's like 4 copies of what we have here, right? This is 1 piece, we want 4 pieces. So what we need to do is take 4 copies of this side over here. In other words, multiply by 4. And this way we would get our answer. We would get that x needs to be -12. We can do the same thing without tiles. Again, our first step is the same. We're adding 3 to both sides. And at this point, we need to think about when we went from x over 4 to x, what we did was multiply by 4. And that's what we're going to do on both sides here. We're going to multiply by 4 on our right-hand side and multiply by 4 on our left-hand side. Now, since our left-hand side is a fraction, multiplying by 4, it's easier to think of this as 4 over 1. 4 and 4 over 1, those mean the same thing. We use that a lot when we were multiplying with fractions. And that means that we can now do some cross-reducing. We've got a 4 on the top, 4 on the bottom here. So that tells us that our left-hand side is going to be x times 1, which is just x, divided by 1. And this would be equal to -12. But like we said, 4 over 1 is the same as 4. X over 1 is the same as x. And we get our same answer using tiles and without tiles. Don't forget to check though. We want to use x equals -12, and we're going to substitute that into our equation where we see x. So we'll get -12 over 4 minus 3. And we want to see, does that equal -6? Well, -12 divided by 4 is -3. -3 minus 3 is -6, so we get both sides to be equal. We know we got the right answer. Alrighty folks, 4 questions on the screen here. Grab a piece of paper and pause the video, try them out for yourself, and we'll go over the answers in just a minute. All done? Alright, let's go over the answers. Negative 2x plus 1 equals 5. Let's first draw this out. It would look a little bit like this. Now our first step is we want to get rid of this number next to our variables, so we are going to subtract 1 from both sides, or add a negative 1. Those would cancel out here, these would cancel out here. We would finally be left with this right here. Now we can use our same trick that we did beforehand, and notice that we can group the top and the bottom here, and we would end up with this right here. This tells us that our negative variable is equal to positive 2. But that doesn't really answer the question. We want to know what this variable x is. Well, if the negative version of this variable is positive 2, well, that tells us that the positive version would have to be equal to negative 2. So this would be our answer. Let's quickly check this. Negative 2 times negative 2 plus 1, does that equal 5? Negative 2 times negative 2 gives us positive 4. 4 plus 1 gives us 5. So we do in fact have the right answer. Similarly over here, in this case we've got to draw out our x over 3 in a diagram like this. Just like before, we want to get rid of all of these numbers next to our variable, so we're going to add 3 in this case. And make sure you do the same thing on both sides. This is where we would end up. Now what we want to solve for is not 1/3 of our variable, we want to solve for the whole thing. So that would be like this diagram all colored in, which means we would need 3 copies of this diagram, right? 1, 2, 3 pieces. We would need 3 copies of our other side over here. And using this, we can get our answer that x is equal to positive 6. Again, we want to check this by substituting in x equals 6 into this equation right here, and checking, does this equal negative 1? 6 over 3 is equal to 2. 2 minus 3 is equal to negative 1. We get both sides to match, we know we got the right answer. For these ones down here, we don't need to use tiles. And in this case, for our first one here, remember we want numbers on one side, variables on the other, so let's get rid of this number right here. We've got a negative 6, so let's add 6 to both sides. From here, we want to get rid of this number in the front. If we look back at our previous examples, where we had a number leading here, we want to divide by that number, because that'll cancel it out. So if we have negative 4 copies of our variable here, we want to divide by negative 4. Those would cancel out here and here, leaving us with our variable z is equal to 16 over negative 4, which is negative 4. Once more, we want to check this. So let's take negative 6 minus 4 times negative 4. Negative 4, that's like positive 16. Negative 6 plus positive 16, we get that 10 equals 10, so that tells us that we got the right answer. Lastly here, again, we want to move our numbers onto one side, so we're going to subtract 3 from both sides of our equation here. Negative 5 minus 3 is negative 8. Now in our previous examples, anytime that we had a fraction here, we had to multiply by our denominator to cancel it out. So in this case, if we have 5 in the denominator, we want to multiply this side by 5 and do the same thing on the other side. Multiplying by 5 is like multiplying by 5 over 1. We can cancel these out, and we would just end up with our variable on the left-hand side, and on our right-hand side, negative 8 times 5 is negative 40. Again, we want to check our answer, so we would substitute in negative 40 and see if both sides of our equation match. Negative 40 over 5, that's like negative 8. Negative 8 plus 3 is negative 5, and we get both sides of our equation to match. We know we got the right answer. Thanks for tuning in, folks. Make sure you check Teams for all the daily homework and as well as any other assignments or activities, and I will see you all in the next video.